Alright, so I think I've got 20 left. Maybe I can do this. This is 5-2 polynomials, which is easy. I think there's some graphing in here, which is a little harder. Anyways, first off is function notation. Basic function notation. To find g of 3, you would let x be 3. And I guess if you were sitting at home, you could do this on TI-84, but I'm going to do it without a TI-84 because I can. That's 27 plus 9, take away 9 quarters plus 10. If I put all the whole numbers together there, I think I got 46. So 46 take away 9 quarters. In order to combine a whole number and an improper fraction, you have to have the same common denominator. So 4 times 46 is 184. So I have 184 fourths minus 9 fourths. And that's what, 175 quarters? Obviously, this is a good place for you guys to use the storage feature because it's just something over and over and over. So 3 stored to x. And I'm going to check myself because you guys can hear me talking right now. I'm not my usual self. 43/75. Still good enough though, 175 quarters. So g of -5, you would plug in a -5. As I get trying to teach kids and tell kids that, you should try and do things by hand. You should try to do things by hand. Because you can do things by hand. This is -125. This is +25. Then we've got 15 quarters. And then we've got plus a 10. So that's going to be -90, I believe, plus 15 quarters. And -90 as a quarter is going to be -360 quarters, which is going to be -345 quarters. Please don't put decimals here. Please don't do that. No. Just no. Can't stand decimals. Whoops, I don't even know why I'm doing that. I should be using the storage feature. That was taking a -5 and storing it to x. There we go. And last up is g of -10. So we'll take a -10 and plug it in. And so a -10 cubed is -1000 plus 100 plus 30 quarters plus 10. Start to put some things together. We'll have -890 plus 30 quarters. If we multiply that -890 by 4, lost my place there. It should be -3560. Quarters plus 30 quarters. That's going to be -35 30 quarters. I wouldn't be surprised a bit if 4 went into that. Of course, it's even, isn't it? It's definitely even. I can do that. That'd be -1700 and... Man, I'm wore out. 130. 1765. -1765 halves. And let's see if I'm right. So this time I took a -10, plugged it in. Looks like I'm right. Sorry, you can't see what I'm doing. That was right. I usually am. So there's 3 more. Let's get done what I can get here. I'm going to leave just a little after 3 today. I'm not staying too long. Describe the end behavior of the graph of the polynomial by completing and writing the statements f of x blank as g of x, whatever. Anyways, we're supposed to complete these statements. What happens to y as x approaches negative infinity, and what happens to y as x approaches positive infinity? It's actually backwards from the notes you took. But this is the power function. It's negative 2x cubed. And negative 2x cubed is going to start its day high. It's going to end its day low. So what happens is, as x approaches negative infinity, f of x approaches positive infinity. And vice versa, as x approaches infinity, f of x approaches negative infinity. 17, my emphasis is right there, 5x to the 8th. That is my power function. It's 5x to the 8th power. That's a positive x to the odd, start high, end high. So as x approaches negative infinity, the y values approach infinity. And as x approaches positive infinity, the y values also approach positive infinity. And here we have some crazy looking thing. It's negative x to the odd. It's going to behave exactly like number 16 did. It's going to start high and low. So I'm just going to recopy that text. As x approaches negative infinity, the y values approach positive infinity. And as x approaches positive infinity, I can look at the graph. My y values approach negative infinity. Ta-da! 19 through 21 describe the degree and leading coefficient of the polynomial whose graph is shown. This is obviously an x to the even. I know that because all x to the even, it is obviously a positive x to the even because they start high and they end high. Think about your quadratics. This upside down W looking thing is obviously a negative x to the even because it starts low and ends low. And this squiggly looking little guy is obviously a negative x to the odd. It's probably a third degree polynomial, but who knows. 22, 23. Graph using your knowledge of end behavior and your ability to make a table. Show me a table. So it's x cubed, which means it's going to start low and it's going to finish high. You can even do a little bit of factoring if you want. To find a x-intercept, you set y equal to 0, and you can pull an x. So, what did I just learn? Apparently nothing. I learned that an easy x-intercept is 0. There's also one at plus or minus root 5, but some of y'all get that, some of y'all won't. But anyways, I know that I cross the x-axis at 0. What else do I know? I don't know. Got to make a table. So, make a table. And I'm going to cheat because I'm tired. It's a nice little feature in a TID4. It's called table. It's right there in blue. It's really bright in here. Anyways, there's some numbers I can plug in. This thing goes from 3, 6, 9. Oh, cool. It goes all the way up to 12 and down to 12. So I can actually grab this negative 3, negative 12, negative 2, 2, negative 1, 4. There's 0, 0. 1, -4, 2, -2, and 3, 12. There's a whole bunch of good points grabbed straight out of a TI-84. So back 3 down 12, that was expected. Back 2 rise 2. Back 1 rise 4, 0, 0. To the right 1 fall 4. To the right 2 fall 2. To the right 3 rise 12. There's my dots. Connect said dots in a nice smooth manner as I move from left to right. And that's what the graph looks like. It's not hard to do. It's really not. This is x to the fourth minus 2, which would have, should be a w. It's going to cross the x-axis at plus or minus root 2, about 1.41. So it's going to cross, even with our rough sketch, somewhere about right there at the tip of my fingernail there, and somewhere about right there too. It has a y-intercept of -2. If you're asking how I know that, you're obviously not paying attention. To find a y-intercept, you let x be 0. Oh, by the way, it's x to the fourth. It's going to start high and it's going to end high. It's probably going to have a W shape in the middle. But I'm going to do this the same way I did that one. Oops, didn't mean to hit graph. It doesn't have a W shape. It's kind of surprising. So there's my table of values. The only ones I can actually pull are -1, -1, 0, -2, and 1, -1. Can't pull the rest of them. I'm going to write them down though. -2, 14, -1, -1, 0, -2, 1, -1, 1, 14. So -214 is off the grid, expected behavior. -1, -1 is right there. 0, -2, 1, -1. That should be a 214, which is off the grid. I was kind of hoping this thing would have a little curvature. I don't know why I said it would be a W. Looking at it again, I understand why it's not. It's just a really narrow parabola. That's all it is. 23. 24 is a graphing calculator problem, so I'll go ahead and do it while I've got a graphing calculator out. From 1992 to 2003, the number of people in the United States who participated in snowboarding can be modeled by S is 0.0013 t to the fourth minus 21 thousandths of t cubed plus 84 thousandths of t squared plus 37 thousandths of t plus 1 2/10. Where S is the number of people in millions, T is the number of years since 1992. Using a graphing calculator, estimate the year the number of snowboarders was first greater than 2 million. So on paper, you're taking your little equation and you're saying, when is it going to be first greater than 2? And it even talks about how to do this, throw something in y1 and something in y2. Of course, we don't have a T button we can use, we have X. Anyways, I'm putting 2 into y2. Why at 2? Because the equation is written in millions. Sorry I'm not feeling the best today. This probably isn't the most entertaining video. It's probably pretty crappy as usual, but at least some days I have energy. So there's what you can see is, of course, none of this stuff over here matters because it's prior to when data was established, so it's all extraneous over here. But we can kind of see this slow increase on the right-hand side. So I'm going to look a little bit to the right, maybe 20 years in the future. Aha! There's a nice clear intersection. So I actually set my X max to be 20. Apparently snowboarding just goes crazy after that intersection. But the X max is 20. And I'm going to hit second trace. And I'm going to choose intersect. Second trace intersect. And I'm going to get close to my intersection. And I'm going to press enter 3 times. And I got that X is about 10. All right, now it talks about T, or in this case X, is the number of years since 1992. X is number of years since 92. So the year, since X was roughly 10, the year is sometime in 2002. Because 92 plus 10 is 2002. And that is all of the energy I have to give you. So I hope that was enough. I hope that I hit the actual record button and I hadn't just been talking to nothing. Sweet. Till tomorrow.